Let's enable the automatic startup of PINet with VMS. We'll do that by editing the site-specific startup file for VMS, which can be found in the sys$manager directory. Normally PINet is the last thing started up, so we'll jump down to the end of this file, and you can see I've added the command in here already. I was a good citizen and I put in a comment that says what I was doing and the date and gave my initials here so somebody knows who to ask or blame for this. We're using a submit command. The submit command allows us to run this in the background so we don't hold up the startup and hold up the ability to log into the machine for other applications. Another advantage of using the submit command is it allows us to delay the startup of PINet, and this may be important because the site-specific startup file executes in a different thread of the VMS startup than things such as the network and X windows. PINet depends on the network and X windows, so it doesn't make sense to start PINet until those other things are completed. So by inserting a little delay here, about 3 minutes to 5 minutes on a VAX, could be as little as 30 seconds or a minute on an alpha computer. This delay here assures that the other thread of processing where the network is gets done before the PINet attempts to start up. What other options I use here? I ran this as a user system, so the submit command allows me to control who runs this. We need to be the system user of VMS, the administrator, to run this. And I've disabled printing a trace of the execution of the startup file, but I did enable a bell character being sent to the console to let people know Pi was started up. And for troubleshooting purposes, I kept a log of the startup. Logs being set to the sys$manager directory. Some system managers send this to the PINet directory instead. Your choice. Be careful to ensure that you get the disk name for your installation set correctly. Our computer has a disk called DKA300 where we've installed PINet. So I use this as the command to start up PINet. We also want to make sure that PINet is automatically shut down whenever VMS is shut down. And we'll accomplish this by editing the site-specific shutdown procedure for VMS. This is called syshutdwn.com. It's in the sys$manager directory. In the same way that PINet was normally the last thing started up, normally PINet is the first thing shut down. So I'll open up a couple of lines here, and as before I'll put in some sort of comment that says stopping PINet, and put in the date. And my initials so somebody knows who to ask questions of or blame if there's a problem with this. And the command we're going to use is very simple. We can use the PINet logical name because the PINet logical name will be established because PINet's running. On startup though, we had to type in the fully qualified path to the command files, but here I can just use the PINet logical name. .com on the end here is optional. One of the things that we'll want to do is give some thought to the behavior of overrange and underrange on our PINet node. The default is that there's no overrange or underrange checking for snapshot values being written to the PINet node. If you want to change that, what you can do is edit this command file that PINet comes with, set snap check range. And if we type this out, you'll see that there's a symbol here and a parameter passed to it. And you can see this is hard-coded here. The reason why this is hard-coded is that PINet runs this during the startup each time. So if you want to change the default behavior from no range checking to having range checking, merely change this 0 to a 1 and save the file. At that point then, whenever there's a put snapshot for real tags, the values will be checked against the configured range for the point. And if the range is within the allowed range, you'll write a good value, and if the range is over or under, then it'll be recorded as a bad quality event instead. PINet, like almost all pieces of software today, as new versions come out and so on, have small changes in their resource requirements. By this I mean disk and memory and other resources of the computer. We strongly recommend that you document the cost of a couple of system resources as part of your installation and upgrade of PINet, and that you monitor this over time so that you can be aware of the creep in the cost of these resources. In the PINet build directory, there's a couple of executable programs that are named PINet something.exe, and they're the global pages program and the virtual page count program. So what we recommend is that you run these and document the settings reported there, and keep that in a safe place. Most of you have a logbook that you keep with the systems, or perhaps a file folder that contains notes and so on from significant events like upgrades and software installs, and that's where you want to keep this stuff. What we can see here is that the PINet that we're running costs us 6,403 global pages. Yours will probably be different than this. The cost of global pages for PINet depends on a number of system variables, including things like the license limit for tags, whether we're on Vaccine Alpha, and other things. Also note here that depending on the interface, you may need additional global pages. Here we see that our system currently has 62,000 global pages, and that there are 21,000 free global pages. So our system's pretty healthy in the global pages configuration area. On a VAX, we recommend that you've got 4,000 to 6,000 free global pages. So after installing and running PINet, if you don't have at least 4,000 to 6,000 free global pages, that's something you probably should address. The other program monitors virtual page count. And we see here that our PINet node needs about 40,000 virtual pages. Virtual pages are the virtual memory needed by a program or a process for its code and data. The virtual page count will vary from system to system. In older versions of VMS, virtual page count corresponds directly to a system parameter of the operating system that you can set. In newer versions of VMS, this has been replaced by a couple of other parameters. Turns out you can still set this in modparams.dat and use AutoGen to configure it, and the system will figure out the differences here. Typically, I try to use the virtual page count parameter so that it's large enough, and even larger than required. So I might have set virtual page count on this machine for 70,000 pages instead of the 40,000 that's asked for here. One thing to watch though is that your page file be large enough to accommodate all the virtual memory that you're going to be asking for.